So next question. Using the properties of determinants, prove that a minus b minus c 2a 2a 2b b minus c minus a 2b 2c 2c c minus a minus b is equal to a plus b plus c whole cube. So again we need to solve this example using the properties of determinants. So we'll consider the LHS. So the first step we need to apply is R1 implies R1 plus R2 plus R3. So on applying the operation we get the first row elements as a plus b plus c, a plus b plus c and a plus b plus c. The elements of R2 and R3 will remain as it is. Next, second step, we will take out the common factor a plus b plus c from the first row. So the elements will be 1 1 1, 2b b minus c minus a, 2b 2c 2c c minus a minus b. Next we will apply the property on C2, that is C2 implies C2 minus C1. So when we apply the property C2 minus C1, 1 minus 1, it will be 0. B minus C minus A minus 2B gives minus B minus C minus A, and 2C minus 2C will be equal to 0. Next we will apply the property on C3, that is C3 implies C3 minus C1. So again 1 minus 1 we get 0, 2B minus 2B will be 0, and C minus A minus B minus 2C will be minus C minus A minus B. Now we will expand it using R1, as R1 consisting of maximum number of zeros. So we use R1 to expand the determinant. So a plus b plus c into 1 into, so minus b minus c minus a into minus c minus a minus b. We get a plus b plus c. So when we take out minus c common, we get b plus c plus a, and again when we take out minus 1 common from the second term, we get c plus a plus b. So minus 1 into minus 1, it will be plus 1, and we can see that a plus b plus c is repeating 3 times. So we get a plus b plus c whole cube, which is the required RHS. Next, we will consider another question. Using the properties of determinants, prove that x plus y plus 2z xy, z y plus z 2x y, z x z plus x plus 2y is equal to 2 times x plus y plus z whole cube. So again we will consider the LHS. Okay, now in the RHS we require 2 times x plus y plus z whole cube. So when we apply the operation C1 implies C1 plus C2 plus C3, the elements of C1 will be 2x plus 2y plus 2z. When we take out 2 common, we get 2 times x plus y plus z. Similarly, the second element of C1 will be 2 times x plus y plus z, and even the third element will be equal to 2 times x plus y plus z. The elements of C2 and C3 will remain as it is. Taking 2 times x plus y plus z common, the elements of first column will be 1 1 1, x y plus z plus 2x x, y y, z plus x plus 2y. Next we will keep the first row as it is and try to apply the operations on R2 and R3. So on R2 we will apply the operation R2 implies R2 minus R1. So first element of R2 minus first element of R1 we get 0. Next, second element minus second element, we get y plus z plus x, and y minus y, that is third element, we get again 0. Next, we apply the property on R3, that is R3 implies R3 minus R1. So 1 minus 1, again we get 0, x minus x will be 0, and z plus x plus 2y minus y gives us z plus x plus y. So we can take out x plus y plus z common from R2 and R3. So we get 2 times x plus y plus z, x plus y plus z, and x plus y plus z multiplied by the determinant 1x, y, 0, 1, 0 and 0, 0, 1. So we'll expand the determinant. Now we can see that the row R3 consists of maximum number of zeros. So we will expand it using R3. So we get 2 times x plus y plus z is repeated 3 times. So we get x plus y plus z whole cube. And the first 2 elements of R3 are 0. So only we need to multiply it with the last element, that is 1. So 1 into we get 1x 0 1. So on simplifying, 1 minus 0. So 1 into x plus y plus z whole cube, we get 2 times x plus y plus z whole cube, which is the required RHS. Next question, prove that b plus c a, b c plus ab, c a plus b is equal to 4 times a plus b, 4 times a into b into c. So again consider the LHS. So we will apply the property R1 implies R1 minus R2 minus R3. So on simplifying, we get 0 minus 2c minus 2b, b c plus a and b, c and a plus b. Next, we will expand it along R1. So the first element, that is 0 into any determinant, will be 0. Next, minus 2c into determinant bb c a plus b, and third element minus 2b into b c plus a, c and c. So 0 into any determinant will be 0, minus into minus 2c, it will be plus 2c. So b into a plus b, it is ab plus b square minus bc, and minus 2b into bc minus c square minus ac. Now we simplify it further. So 2c into ab, it will be 2abc, 2 plus 2cb square minus 2bc square minus 2bc square plus 2bc square and plus 2abc. So 2abc plus 2abc will be 4abc, 2cb square and minus 2b square c will cancel off. Similarly, minus 2bc square and plus 2bc square will cancel off. So the remaining elements will be 4abc, which is the required RHS. So next, using the properties of determinants, prove that 1x x square 1x x square 1 is equal to 1 minus x cube whole square. So again consider the LHS, 1x x square 1x x square 1. So if we observe, the elements of each row are in cyclic order and all the diagonal elements are same, so we can apply C1 implies C1 plus C2 plus C3. So we get 1 plus x square, 1 plus x square and 1 plus x square as the elements of the first column. So taking out 1 plus x square from the first column we get 1 1 1 x1 x square x1. Next we will fix the first row as it is and apply the operations on R2 and R3. So on R2 we will apply the operation R2 implies R2 minus R1. So first row elements will remain as it is. So the first element of the second row minus first element of the first row we get 0. Next second element minus second element we get 1 minus x. Third element minus third element we get x minus x square. Next we apply the property on the third row. So R3 implies R3 minus R1. 1 minus 1 again we get 0. X square minus x and 1 minus x square. So now in the second row we can take out 1 minus x. So first we will simplify the third element of the second row, take out x common, so we get 1 minus x. Similarly in the third row, if I take x common in the second element, I get x, we get x minus 1. Next we will take out 1 minus x common from R2 and R3. So we get 0 1 x, 0 minus x, 1 plus x. Next we will expand it using C1. So 1x x square, 1 minus x, 1 minus x into. So only the first element is simplified, rest of the elements are 0. So first element, that is 1 into 1 plus x is 1 plus x, and x into minus x is minus x square. Minus of minus x square, it will be plus x square. So we get 1 plus x square, 1 minus x, 1 minus x, 1 plus x square. So 1 minus x factor is repeating twice and 1 plus x square is repeating twice. So on simplifying, we get 1 plus x square whole square and 1 minus x whole square. So we can see that in the RHS we require 1 minus x cube whole square. When using the identity a cube minus b cube, we get 1 cube minus x cube is equal to 1 minus x into 1 plus x square. So we are grouping the terms 1 minus x cube into 1 minus x cube, which is nothing but 1 minus x cube whole square, which is the required RHS. Next question. Show that 1 plus a 1 1 1 1 plus b 1 1 1 1 plus c is equal to abc into 1 plus 1 by a plus 1 by b plus 1 by c, which is equal to abc plus bc plus ca plus ab. So solution, consider the LHS. So we need to rearrange the terms in the LHS. So to do this, first we take out a, b, c common from R1, R2 and R3. So a, b, c is common. So we get 1 by a plus 1, 1 by a, 1 by a. Next in the second row we are taking out b common. We get 1 by b, 1 by b plus 1, 1 by b. And in the third row we get 1 by c, 1 by c, 1 by c plus 1. Next, applying the property R1 implies R1 plus R2 plus R3, we get ABC into 1 plus 1 by A plus 1 by B plus 1 by C, 1 plus 1 by A plus 1 by B plus 1 by C, and third element is also 1 plus 1 by A plus 1 by B plus 1 by C. Next, the element of second row and third row remain as it is. So taking out 1 plus 1 by A plus 1 by B plus 1 by C common from R1, we get ABC into 1 plus 1 by A plus 1 by B plus 1 by C, 1 1 1, 1 by B, 1 by B plus 1, 1 by B, 1 by C, 1 by C, 1 by C plus 1. So now we fix the first column as it is, and then apply the property on the second and third column. So C2 implies C2 minus C1. We get, so first element of C2 with first element of C1, we get 0. Next 1 by B plus 1 minus 1 by B, it will be 1, and 1 by C minus 1 by C will be equal to 0. Similarly, apply the property on C3. C3 implies C3 minus C1. We get 1 minus 1 is 0, 1 by B minus 1 by B is 0, and 1 by C plus 1 minus 1 by C is equal to 1. Next, we will expand it using the first row. So we get 1 into 1 0 minus 0. So on simplifying, we get the required RHS. We can get the RHS in some other form by taking the LCM and simplifying. So when we take the LCM and simplify it, we get ABC plus BC plus CA plus AB, which is the required RHS. Next question, using the properties of determinants, prove that 1 plus A square minus B square, 2AB minus 2B, 2AB 1 minus A square plus B square, 2A, 2B minus 2A 1 minus A square minus B square is equal to 1 plus A square plus B square whole cube. So again consider the LHS. So we will apply the property C1 implies C1 minus B C3 and C2 implies C2 plus A C3. So first we will apply the property on the elements of C1 using C3. So first element of C1 is 1 plus A square minus B square, and we are multiplying the first element of C3 with B and simplifying. So we get 1 plus A square minus B square minus B into minus 2B, which is equal to 1 plus A square plus B square. Second element of C1 minus B into second element of C3, we get 2AB minus 2AB, which is equal to 0. Next third element 2B minus B into 1 minus A square minus B square, which on simplifying we get B plus BA square plus BB square. So on taking B common, we get B into 1 plus A square plus B square. So the elements of C1 will be 1 plus A square plus B square, 0, and B into 1 plus A square plus B square. Now we apply the property on C2, that is C2 implies C2 plus AC3. So first element of C2 is 2AB plus A into the first element of C3. We get 2AB minus 2AB, which is equal to 0. Next second element of C2, 1 minus A square plus B square plus A into 2A, which is equal to 1 plus A square plus B square. Next third element, that is minus 2A into plus A into 1 minus A square minus B square. So minus A cube minus AB square. Now we will take out minus A common. So the element will be minus A into 1 plus A square plus B square. So keep the elements of C3 as it is. So further we can see that 1 plus A square plus B square is common in C1 and C2. So when we take out 1 plus A square plus B square common from C1 and C2, we get 1 plus A square plus B square whole square. So the remaining elements will be 1 0B 0 1 minus a minus 2b 2a 1 minus a square minus b square. So further we apply the property R3 implies R3 minus b R1 plus a R2. So using the property we get 1 0 minus 2b 0 1 2a, that is the elements of first row and the second row remain as it is, only changes take place in the element of R3. So we get R3 minus b R1, and this will be 0, and then R3 minus b R1 plus a R2, it will be 0. So the third element will be 1 plus a square plus b square. Now expanding using C1, we get 1 into 1 plus a square plus b square, and 0 into 2a is 0. So on multiplying 1 plus a square plus b square into 1 plus a square plus b square whole square, we get 1 plus a square plus b square whole cube, which is the required RHS. Next question, using the properties of determinants, prove that a square plus 1 ab ac, ab b square plus 1 bc, ca cb and c square plus 1 is equal to 1 plus a square plus b square plus c square. So again we can see that the LHS is not containing the term present in the RHS. So here we take out common factors a, b and c from R1, R2 and R3. So we get a, b, c into a plus 1 by a, b, c. Next in the second row we are taking out b common, and in the third row we are taking out c common. So next we get a, b, c. We will multiply c1 with a, c2 with b and c3 by c. Since we are multiplying to cancel off the terms, we divided by abc. So abc divided by abc. Okay, so each column we are multiplying with a, b and c. So first column we are multiplying by a, we get a square plus 1, a square and a square. Similarly second column we are multiplying by b and third column by c. So now ABC divided by ABC will cancel off, we get 1, and then after applying the property C1 implies C1 plus C2 plus C3, we get 1 plus a square plus b square plus c square as the elements of first column. The elements of C2 and C3 will remain as it is. So take out 1 plus a square plus b square plus c square common from C1, we get 1 1 1 b square plus 1 b square c square and c square plus 1. So again we will fix the first row as it is. We will simplify the second and third row. So we will apply the property R1 implies R1 minus R2. So we get 1 minus 1 is 0, b square minus b square minus 1, it will be just minus 1, and c square minus c square will be equal to 0. Next we will apply the property on R2. R2 implies R2 minus R3. So 1 minus 1, again it will be 0. Next b square plus 1 minus b square will be 1, and c square minus c square plus 1 will be minus 1. So further we expand it using C1. So 1 plus a square plus b square plus c square into minus 1 minus 1, it will be plus 1. So on simplifying we get the required RHS.